Hey guys, this is a lesson on combining like terms. Now before we get started, we need a couple of definitions. So right here we just have a variable expression, which is just like you remember is a set of numbers, variables, and operations happening within those numbers and variables. So the first definition you need is a term. So a term is a part of the expressions that are added together. So looking at this example, the terms of this example are 3x, 2x, 2, 5, and 4. These are all terms because those are the parts that are being added together. Okay? Next is coefficients. Coefficients are the number part of a term with a variable. So remember what the variables are. Variables are the letters, right? So in this case, the variables are the x. So the coefficients of these variables are 3 and 2. So in this example, 3 and 2 are coefficients. Next is the constant. A constant is a number in an expression with no variable. So looking here, the 2 has no variable, the 5 has no variable, and the 4 has no variable, so those are all the constants. And then lastly, we have like terms. Like terms are terms that have identical variable parts, including exponents. And this is a biggie. We'll get to that in a second. So looking here, the variable here is x. The variable part here is x. We don't have a variable part here, here, nor here. So the like terms in this case are 3x and 2x. That's one set. And then this set over here, these are all like terms because they all don't have variable parts, so therefore they're alike, right? All right, so let's look at the first example. The first one is just to identify the like terms. So looking at A, the like terms in this expression, we have to look at the variable parts first. So looking here, we have an x squared. And if you remember from before, terms that have identical variable parts have to include the exponents. So the first part only has one x squared term, and there's no other x squared term. So this is by itself. So x squared is by itself. The next one is the x terms. So we have this x term over here with the 5x, and we have this x term here with the negative 3x. Those are the like terms. So 5x and 3x, those go together. The next set is looking at this negative 4. It has no variable attached to it. There is another term over here with no variable attached to it, so those are like terms. So negative 4 and 2 are also like terms. Looking at B, we'll go again from left to right. We have x squared. That's only one by itself, so negative 5x squared is by itself. It has no other terms that are like it, right? The next is the x terms. We have this x, but look at the sign that's in front of it. That is a minus sign. Remember, stop thinking these as subtraction. This is a negative sign. That negative is attached to that x. So that is a negative x, right? That is a like term with anything else with just an x next to it, and that's this one over here. That's 6x. So 6x is a like term with it. Next is the constant terms. We have an 8 over here, and then you see that? Negative 10 right there. So 8 and negative 10 are also like terms. Last grouping we have here is this one over here with the x squared. We have another x squared over here, so the like terms are negative 3x squared and x squared. Next is just the x terms. So looking here, we have a 2x and a 7x. So 2x and 7x are like terms. And the last one is just the constant. The constant is kind of by itself. It's not like terms with anything. Whoops. So just write it by itself. Okay? So the like terms are the ones with the same variable part. Now we're going to have to learn how to combine like terms. So there are steps for combining like terms. First, you have to identify what the like terms are, like we did in the last example. And we're going to always start with the order of the higher exponent value. So we did this naturally. The x squareds were done first, then the x's, then the constants were done last because there was no exponent for that one, right? Next thing you have to do is to combine the coefficients. All right, so combining them using integer operations like we've been doing. And the third part is just to repeat this process until only the constants are left, and then you just got to combine the constants. All right, so let's do the first one. Identify like terms. We have this x squared term and this x squared term. And again, we're starting with the highest exponent value, which were the x squared terms. So now we have to go to step 2, which is combine coefficients. We're going to combine the coefficients. The coefficient here is -3. And you see there's no number in front of here, but that no number just means that there's an invisible 1 in front of it. So -3 plus 1 is -2. So I'm just going to write that over here, -3 plus 1. We're combining the coefficients, but we're leaving that variable there. -3 plus 1 is -2x squared, right? And now we're done with the x squared terms. We're going to repeat this until all the only constants are left. So the next one is the x term. So we have this x term here and this x term here. So we're going to have to combine 2x and 7x. So adding their coefficients, combining their coefficients, we're left with 2 plus 7, and that's going to be the x term in our simplified expression. 2 plus 7 is 9, and that term just has an x. Okay? And then the last part is repeat until only constants are left. We only have this one constant left right over here. There are no other constants to combine it with, so we just write -4. And then you're done. You cannot combine this, you cannot simplify this any further because there are no more like terms. You can only combine things that have the same variable grouping attached to it, okay? So even though these two are x's, you can't combine them because this one has an x squared and this one does not have that square. All right? Next, we're going to be simplifying expressions with distribution. So the first thing you need to do is distribute and then combine like terms. So let's do the distribution first. So in this first one, we're only going to be distributing the 5 and not that 7, only the 5 gets passed along. So 5 times x and then 5 times 3. So we're just going to rewrite that 7. And then 5 times x, which is 5x. And then plus 5 times 3, which is 15. From here, combine like terms, starting with the highest exponent first. So we only have this x value. There's no x squared this time. So now we're just going to find like terms with this, 5x. There's nothing else with an x attached to it, so we're just going to rewrite it, 5x. Right? So we're done with that. And now we're going to combine the constants. We have a 7 here and a positive 15 here. 7 plus 15 is 22. So plus 22. And then we're done. 5x plus 22 is our final simplified expression. The next example, first you have to distribute, then combine like terms. So we're going to have to distribute. So let me just move this problem down. All right. So we're going to have to distribute that negative. Remember, this is a -1 that we're distributing to everything inside the parentheses. -1 times x and -1 times 2. We're going to be left with -x plus -2. And in the second one, notice that we're not just distributing the 2. We're distributing that -2 into everything inside the parentheses. -2 times 1 is -2. -2 times -x. Negative times negative make positive. We're going to be left with plus 2x. Okay? And then from here, combine like terms, starting with the highest exponent value. We only have x terms here, so we're going to start off with x. So we have this x term over here and this x term over here. Remember, think of that little negative sign as just a -1. -1x plus 2x, -1 plus 2. All right, that's our first operation. -1 plus 2 is 1, so we're going to be left with 1x. All right, then we're done with those. Then the last one is just the constants. We're left with -2 plus -2. -2 plus -2 is -4. Right? So our final expression is 1x minus 4. You don't have to write the 1 there, so you could just write x minus 4 as a final statement. All right? So I want you to try these 4 problems, pause the video, see if you got it, and then fast forward to the solutions and see if you're right. All right, I'm going to go over these. 2 times x is 2x, 2 times 3 is 6, 3 times 5 is 15x, or 15, and 3 times negative x is negative 3x. Combine like terms, we have 2x and negative 3x. That's going to be negative x. And then we have the constants, 6 and 15, and that make positive 21. So that's the first one. The second one, we have 3y plus 6 minus 4y, right? The like terms in this case are the y values, 3y and negative 4y. 3 minus 4 is negative 1, so we're going to be left with negative y plus 6. All right. Problem number 3. We have negative x squared plus 5x plus x squared. Notice that these are the x squared values. Those are the like terms. Negative x squared plus x squared, that's a negative 1 plus 1. And negative 1 plus 1 is 0. So we're left with 0x squared. Right? The last one is the 5x. There's nothing to combine it with, so we're just going to rewrite it down here. So anything times 0 is 0, so therefore we don't even have to write this part down. So thus our final answer is just 5x. And then the last problem. We have to distribute that negative sign into everything inside of the parentheses. So think of it as a negative 1. We're just going to rewrite this 3y plus negative 1 times y squared is negative y squared. Negative 1 times 2y is negative 2y, and then minus 5y. Right? Next, we're going to look for the like terms, starting with the highest exponent value. The highest exponent value within all of these is the negative y squared. There's no other y squareds within this problem, so we're just going to rewrite it down here. Negative y squared. Next is the y terms. We have this y term, and this y term. Right? So we're going to combine their coefficients. 3 minus 2 minus 5. So we're just going to write that like this. 3 minus 2 minus 5. And put a y next to it. 3 minus 2 is 1. So I'm just going to rewrite this. That's going to be 1. 1 minus 5 is negative 4. So that's our coefficient. All right. The last example is finding the perimeter of a rectangle. So remember, finding a perimeter is adding up all of the sides. So we have a 2x here. Since it's a rectangle, this is also going to be 2x, even though it wasn't written down. We have a x minus 7 over here. So on the other side is also x minus 7. So we're going to add up all 4 of the sides together. So we have 2x times 2, because there's 2 sides, plus 2 times x minus 7. Right? 2 times 2x is 4x, plus 2 times x is 2x. All right, after we distribute to the first one, distributing to the second one, we're left with 2 times negative 7, which is negative 14. Now we're going to combine like terms. We have this term that's the same as this term. 4 plus 2 is 6, so 6x minus 14, because that constant can't be combined with anything, and we found the perimeter. Remember, when it comes to these kinds of problems, you always have to put units. For this one, you weren't given units, so we're just going to write down units, just to be safe. All right, and that's it.